These past couple weeks, we have been doing our unit on sound, and this is just going to be a quick review over what we have learned and what will be on our quiz tomorrow. So the first thing we're going to learn about is the word emit. To emit a sound means to make a sound. That's really all it is. We make sounds by speaking, by singing. We make sounds by tapping our foot, and our iPhones make sounds when they ring or when there's an alarm going off. Sound is energy that is produced by vibrations. Kind of hard to understand, but these vibrations and this energy is created when any two objects meet together. So when you imagine yourself slamming your fist on your desk, when your fist meets that desk, it is creating energy and creating vibrations. Those vibrations are what the sound is, and those vibrations are traveling through different mediums to reach your ear, which is how you're able to hear it. Even something simple as tapping your pen on a piece of paper. It's a small sound, it's a very soft sound, but when that pen hits the paper, it is creating vibration that is just energy, and it's creating sound. That is what you are hearing. It's vibrations and it is energy. Echo is when a sound bounces or reflects off of a surface. So the most common example is when you go in a big empty cave. There's not a lot of objects there, it's just big empty walls. And when you say something, what your sound does is it's bouncing directly off these big empty walls, and it's reflecting and coming back at you at different times. So if you go somewhere huge and open like the Grand Canyon and you scream, you're going to hear a lot of different sounds bouncing back and forth. Even if you were in an empty room with just four walls, nothing else in there, you're going to hear a slight echo when you scream or when you make a noise, because that sound is reflecting back and forth at you. Now, when you absorb is when a sound is soaked up. It is the opposite. A good example I like to use for this is when we imagine musical artists, when they are recording for an album. They are in a recording studio. And in a recording studio, you're going to always have the walls and the floors and the ceiling. Everything's going to be covered with a soft material, usually carpet. The reason that is because they don't want any sound getting in, and they also don't want any sound escaping that room. They want it all staying in there. So when this musical artist is creating their music, all of that music is being absorbed into these soft walls, into the ceiling, into the floor. All of this soft material is absorbing that sound. It's soaking it up. Next part is, pitch. Now we want to know the difference between pitch and volume. Pitch is how high or low a sound is. Now I know when you think of volume, you also think, well, I have the volume up high and I have the volume up low. But when we're talking about this, you want to focus on pitch being about how high or low a sound is. High pitch is when, if you say the word eek and you actually use a high pitch, I'm not going to do that for my YouTube video, but I'm sure your child can do it to show you. That's going to create a very high sound. Another example would be like a tea kettle that was going off, or a car horn that's beeping very loud. That's kind of like a high pitch. A low pitch is when your pitch is very low. So example we use in class is when you go, ooh. Okay, that is a low pitch. Now, the opposite of pitch is what we're focused on as well, is volume. Now, it's important to understand the difference between volume and pitch. Volume is how loud or soft a sound is. When we're talking about volume, we don't want to talk about high or low anymore. We're talking about loud or soft. So when we think about volume, I like to use an example like a radio. You can have the radio on and you can have the volume turned to a low, soft. I shouldn't say low, so I'm already messing up. But you should have the volume on a soft volume with just a little bit of music. And then when you crank that volume up, it is getting louder. More louder music is coming out of your radio. Now, volume can also relate to pitch. So for our example we used, when I was saying ooh to represent a low pitch, I can say that same level of pitch, but I can make it louder in volume. So for example, I would start as ooh. That is an example of a low pitch getting louder in volume, okay? Now, a medium is any type of matter a sound vibration can travel through. Now, this is a solid, liquid, or gas. The only way we can hear sound is if it travels through one of these things. Now, obviously, all the sounds we hear every day are typically traveling through gas, which would be just traveling through the air. That's how we're hearing them. But it has to travel through one of these three mediums. Now, when it travels through different mediums, we have a solid, a liquid, and a gas. Sound travels best through a solid because this type of matter is very solid, it's very compact, and the vibrations can just very simply in a straight line travel right through that. Now, when it comes to a liquid or a gas, it doesn't travel quite as well through these two because it's not as solid as a solid is. Now, one example we like to use is if you had two people in space and they didn't have any type of communication device or anything like that. If these two people were in space and they were trying to communicate, they would not be able to hear each other at all. Even if you went in space and snapped your finger or clapped or anything normal you would do to emit sounds, you would not actually hear it because there is no gas up in space. There's no oxygen, there's no liquid for it to pass through, and there's definitely no solids for your sound vibrations to pass through. So it's a really interesting fact we like to focus on. Now, last but not least, frequency. Frequency is how rapidly or slowly vibrations move, and this affects the pitch. So when you talk or when you make a noise, your sound travels in vibrations. Now, like an example we had up here with the solid, these sound vibrations are traveling very quickly at a high frequency. This results in a high pitch, okay? So when you make that high pitch sound, your vibrations are moving at a very rapid pace, a rapid frequency. Now, a low frequency means your vibrations are traveling slower or less rapidly, and that results in a lower pitch.